Okay. So this is a review of MyStatLab exercises from the normal probability chapter. Find the area of the shaded region. So he wants the area to the left of z equals 0.43. So to do this, guys, you just do normal CDF to the left of negative 0.43. So this is the lower bound here, guys. When the lower bound is the tail, that will be a negative a million. And then 0.43, and then comma 0, comma 1. And the answer would be clear. Let's just do this quickly. Normal CDF, negative a million, 0.4301. By default, for Z, it's 01. And it would be 0.6664. What did he say? How many decimal places? 4 decimal places. So your answer should be, you just type it 0.664. And that would be the answer. You will see 2 tables will pop up if you want to use the table. I could have used the table if I wanted. To the left of 0.43, it's a positive table right here, guys. 0.4 right here, and then the 3. And look, it's the exact same answer, 0.664. Okay. Number 2, find the indicated area to the right of z equals 1.59. This is it. This is the z equals 0. 1.59 will be somewhere here, and we want this area. Okay, using normal CDF will be normal CDF. Okay, what's the lower bound here, guys, for this one?
1.59.
Yeah. Once you put the lower bound, and the next number should be positive, the million, and then 0, and then 1, and then you get the answer. Okay. So that is number 2. Number 3. Assume the random variable x is normally distributed with a mean of 90 and a standard deviation of 4. What's this probability? Probability of x between 80 and 87. You see, these are the problems in your homework online. We've done them already. So this is going to be normal CDF. 80 is the lower bound. 87 is the upper bound. And then the mean is 90. And the standard deviation, guys, is 4. And then you just round to 4 decimal places. Let me just do the answer for this. You will see an exact similar question to the like that, but with different numbers, of course. 87, 90, and then 4. Yep. And watch, guys. It's 0.2204. So you type your answer, whatever. It's right here. You should type the answer. That's the answer. Number 4. Okay. This number 4, please pay attention to it. That could show up on the test also with multiple parts. It's just like the Socrative activity, like your assignment, very much the same, but it's in parts. So in a recent year, the scores of a reading portion of a test were normally distributed with a mean of 21.7 and a standard deviation of 5.7. He's going to ask you x, find a probability of x being bigger than a number, less than a number, in between. You will see. Find the probability the randomly selected high school students who took the reading portion of the test has a score less than 16. So less than 16. I'm just going to put the what to do, but you guys can do the answer, so I can do most of those problems. Normal CDF less than 16. When it is less than, guys, you start with negative a million, then 16, then 21.7, and then 5.7. And then you can find the answer. And it says round to 4 decimal places here. What's the probability randomly selected high school students who took the reading portion of the test has a score between 16.7 and 26.7? That should be easy when he gives you the 2 bounds. So 16.7, 26.7, 21.7 is the mean, and the standard deviation is 5.7. And then you can find the answer, guys. Find the probability randomly selected high school students who took the reading test is going to be more than 33.6. You see what I'm talking about? Less than, more than, and in between. There is no equal here in the continuous case. So there will be 33.6 for lower bound. What's the upper bound, guys?
1 million.
1 million. And then 21.7 and then 5.7. And you get the answer. Now, in part D, he's asking you identify any unusual events. Here's how you answer this question. If any answer is less than 5%, it is called unusual. So since we didn't do the answers, I don't know which ones are unusual or not. But any answer that is less than 5%, say this is unusual. This is the 5% right here. So unusual means less than 5%. I will scan this document as well, guys, and email it along with the notes from chapter 5. And just please remember, at the end of my chapter 5 notes, there are a couple pages that will show you how to use the calculator if you forget, with the screenshots. So make sure to check them out if you need more help with the calculator. Use a normal distribution of set critical reading scores for which the mean is 504. That's the mean. And the standard deviation is 118. What percent of the set scores are less than 600? So he wants a probability of X less than 600, guys. Percent means the probability. So that will be normal CDF, negative 1 million, 600, and then the mean is 504, and then the standard deviation, guys, is 118. And make sure to put the answer as a percent here, because he wants a percent. So whatever the answer is, you put it as a percent. Round to 2 decimal places. Okay. Let me do this one just to make sure that you know how to put the percent here. So second distribute, normal CDF, negative 1 million, then 600, then 504, then 118, guys. Okay, so 0.79205. What would be as a percent with 2 decimal places? Can someone tell me? What is this as a percent?
79%.
No, but I need 2 decimal places. So 79.21.
20. Oh.
Right? 79.21%. Okay. Okay, B, you would expect that approximate, what is part B? If 1,000 set verbal scores are randomly selected, how many would you expect to be greater than 550? So we need to figure out what's the probability of X greater than 550 first. And that would be normal CDF, 550, 1 million, 504, 118. Okay. In order to figure out how many out of the 1,000 will have a set score more than 550, we need to find this probability. And here's the probability, guys. So you go second distribute, normal CDF, 550, 1 million, and no change to the third and the fourth. Okay, guys, 0.3483. If you have 1,000 of those, guys, and the chance is 0.3483, how would you figure out how many of those 1,000 students will have a set score more than 550? We know the percent, which is 0.3483. What do we do? Multiply 1,000 by 0.3483. 83. If I tell you guys 80% of my students pass the course and I have 50 students, how many will pass the course? You just take 80% and multiply it by 50. And this is the same thing here. But make sure to round to the nearest whole number here because these are people. Okay, number 6. Use a standard normal table or technology to find a score that have a cumulative area of 0.8916. So it's like this. We're going to use technology. This area, guys, is 0.8916, and I want the z-score. So it's an inverse norm. Cumulative is an area to the left always. So you just put 0.8916, comma 0, comma 1, and then you can find the z-score. Any questions? We're still reviewing sections 5.1, 5.2, and 5.3. 7. Okay, he says use a standard normal table. We're just going to use technology, actually. Okay, the z-score that corresponds to P1. And let me tell you what P1 means. P1 means the first percentile, means 1%. So when he gives you a percentile, P1, guys, it's a 1%. 1% means the area is 0.01. So you just take this number right here and convert it to a percent. If I tell you guys you scored on the test in the 75th percentile, it means 75% of the students score below you, to the left of you. So that's what a percentile means. So 0.01. To find the z-score, guys, you already have the area. You go to inverse norm and put 0.01 and then 0 and then 1. It's going to be a negative z-score. You will get negative z-score up to 50%, and then from 50% and up, you'll get positive z-scores. And if you want me to show you how to get this answer, let me show you. Second, and distribute inverse norm, 0.01, 0, and 1. So it's negative 2.33 to 2 decimal places. 8. Who can tell me how to do 8, guys, using the inverse norm? So what would that be? I'll put the second and the third. It's going to be 0, 1. What goes first? What would be the area?
Would it be 1 minus the 0.1230?
Yes, you guys understand why she says 1 minus, because this is shaded to the right. We need it to be shaded to the left. We need the area to the left, so it will be 1 minus 0.1230, and then you just do the math. 9. A water footprint is a measure of the appropriation of fresh water. The per capita water footprint in megagallons in a certain county for a recent year can be approximated by a normal distribution, with the mean of 1.76 and a standard deviation is 2.76. What water footprint will correspond to the 81st percentile? So he's giving you the area to the left, which is 81%, and he wants the x value, not the z value. This time it says x. So this is an inverse norm, guys. Okay, 81st percentile, just change it to a decimal, guys. So it will be 0.81. And can someone tell me what's the mean and what's the standard deviation? It's not 0.1 here because he's asking for an x value. He gave them to us. You can see them right here. So it's 1.76 and then 2.76, and then you can get the answer. He says, did he say round? Yeah, round to 2 decimal places. So make sure to round to 2 decimal places as needed. What water footprint represents the 29th percentile? Okay, I would like a student to tell me how to express this answer here. So 29% of the data is to the left of this value. What would this value be? So what do I put, guys?
0.29,
Comma,
and then 1.76,
comma.
and 2.76.
That is absolutely correct. Okay, let's see if you still remember from chapter 2. What water footprint represents the third quartile? Do you guys know what percent is the third quartile?
Can it be 9.76?
No, third quartile, third quarter.
Oh,
There is a percentage for this one. 50% is the median. First quartile is 25%. What would be the third? It's the middle of the 0.75%, 75%, yes. So it will be 0.75, guys. Oh, then 1.76, and then 2.76, and then you can find the answer. If you see this in the homework online, it says what water footprint represents the first quartile. Instead of 0.75, just use 0.25. If he says represents the 80th percentile, you put 0.8 and so on and so forth. So this is how you answer this question. And 10, the test scores for the analytical writing section of a particular standardized test can be approximated by a normal distribution. This is the distribution, guys. It gives you the mean and the standard deviation. What is the maximum score that can be in the bottom 10%? Bottom 10%, guys, it's on the left. So it's going to be an inverse norm, but can you guys help me put the 3 argument there? What would be the area to the left? It's not a top 10%, it's a bottom 10%. So what is going to be here, the area? Yes?
0.10.
Yeah, 0.10. And then mean is 3.7. And then the standard deviation, guys, is 0.83. And just to show you the answer, it has to be below the mean if it is at the bottom. So second distribute, inverse norm 0.1, 3.7, and 0.83. So it's 2.64. He says 2 decimal places. It will be 2.64. Okay, B. Let's do this and I will stop. And what I will do, the remaining 3 problems, I'll just finish the video myself and make them available. But I'd like you to pay attention to B because you're going to see a few questions in the homework similar to B. What would be between what two values does the middle 80% of scores lie? Let me explain what we mean by middle 80%. So please pay attention to this and then we'll wrap this up. Let me show you what we mean by middle 80%. Means 80% is right in the middle. So if 80% is in the middle, guys, can you tell me what's left for this tail as an area and what's left for that tail?
10 on each side.
Exactly. And how do you figure this out? You take 100% minus 80% is 20%. It's a 10%. So this area is a 10% and this area, guys, is a 10%. He wants those 2 values because there are 2 middle values. Always when you go to the middle, there is one on the left and one on the right. How would you find the first value, guys? Inverse norm. What would that be? I need an area to the left, which is what? 10%. And I need the mean, which is given in the picture right there. 3.7 and standard deviation 0.83.
Can you move the paper up?
Yeah, there you go. .7, 0.83. This is for the first x. Can you guys help me with the second x? How do you find it? It's going to be the larger one. What would be the area to the left of the second x?
Is it the 1 minus?
Yeah, 1 minus 10%. And I'm going to show you a shortcut, guys, in what you do. So it's 0.9, and then 3.7, and then 0.83. Let me show you a shortcut, guys. Let's say you're doing a homework and it's asked you to find, you know, the middle 90 or the middle 70%. Look what you do. Take 100% and subtract the 70%. Or let's do the 80%. 100% minus 80% is 20%. Divide the 20% by 2, you get 10%. So do 10% to begin with, which we did right there, guys. The 0.1. The second one, guys, will always be, what do you need to add to 10% to make it 100? It's a 90%. Look, here's a 90% right here. So this one, the 0.9 and the 0.1 should add up to 1 always. And that's how you do the middle values. So I still have 4 more questions, but time is running out and I have to go to the Learning Lab tutoring now. I will finish this video, guys, and record those 4 questions. And as I promised you always, due dates will always be moved 1 day up to Monday. So if you have any questions on Monday for me, I will answer. Number 11, a population has a mean of 83 and a standard deviation of 27. Find the mean and the standard deviation of the sample and distribution of sample means. So we need here, this is section 5.4. We need mean of x bar and sigma of x bar. And according to the theorem, mean of x bar is the same as the original mean. And this is the same as the original standard deviation, but you must divide by square root of the sample size. So this one will be 83 for the mean, but the standard deviation, it's going to be 27 divided by square root of 254 because the sample size is 254. And if you do the math, 27 divided by square root of 254, you will get 3 decimal places he wants, so it will be 1.694. All right. Next question. We're toward the end. This is section 5.4 now. Number 12. The graph of the annual snowfall distribution in feet for a particular county is shown below on the left with its mean and standard deviation. Assume the sample size of 100 is drawn. So n is 100. And remember, if n is bigger than 30, we don't care if the original population is bell-shaped or not. And as you can see, this original population is not bell-shaped here. Determine which of the graphs below A to C would most closely resemble the sample and distribution of the sample means. So we need to know which graph resembles x bar. This is for x. Remember, for x bar, guys, the mean has to be the same as the original mean, which is the 3.8. But the standard deviation, so that's the mean of x bar. The standard deviation of x bar has to be sigma divided by square root of n. And what's my sigma here? 2.5 divided by square root of 100. And square root of 100 here is 10, so we should get 0.25. So you have to look for a graph from the choices that looks like it's bell-shaped with a mean of 3.8 and a standard deviation of 0.25. And I can see it right here. He tells me here it's 0.25. So that's the correct answer. Okay. And this is the correct graph. And it is a normal curve. It's approximately a normal curve. 13. More applications on section 5.4, the central limit theorem. The population mean annual salary of environmental compliance specialists is about 60,000. A random sample of 40 specialists is drawn from this population. What is the probability that the mean salary of the sample is less than 58,000? Okay, he wants, guys, a probability of X bar less than 58,000. Why did I put X bar? Because he says mean salary. Mean salary means X bar. And it's going to work out the same way as you did before. Normal CDF, you're going to put negative $1 million. You're going to put 58,000. You're going to put the mean, which he says 60,000. But for the standard deviation, you cannot just put the standard deviation. You have to put the original standard deviation and divide it by the square root of the sample size, which is square root of 40 here. N is 40. That's N. Okay, and let's do the math for this one. Okay, so here is normal CDF. You just put it there, paste, and get the answer. It's 0.0146. And if you change this to a percent, guys, it will be about 1.46%. This is unusual because it's less than 5%. And choose the correct answer. So about 1.46% of samples of 40 specialists will have a mean salary less than 58,000, and this is unusual event, so it must be B, not B. D. 1.46% will have a mean salary of less than 58,000. This is unusual event. So your answer will be, you choose part D for the answer. Okay. And the last one. The weight of ice cream cartons are normally distributed with a mean of 11 ounces and a standard deviation of 0.5 ounces. What's the probability a randomly selected carton has a weight greater than 11.14 ounces? So he wants the probability of X more than 11.14. No samples here, guys. So it's just normal CDF. 11.14 million. Mean is what? 11 ounces. And what's the standard deviation? This is the standard deviation, sigma 0.5. So let's do the math. Let me get the answer. Okay, guys, so you can see lower, upper, and then I'm gonna paste. And the answer is 0.3897. That's part A. Part B. A sample of 25 cartons. You see, a sample is involved, so N is 25 now. He's not going to ask you about one individual. He's going to ask you about sample mean, about X bar. What's the probability that the mean weight is greater than 11.14? So you guys can see the difference between the two parts. The first one is about one individual carton. It's X. This is the mean, which is X bar. What's the difference is going to be? Look, this is where the difference will be. Normal CDF, 11.14, it's the same. Look, match. Million is the same. Match. Mean is the same. There's a match. The only mismatch is going to be here. 0.5, you have to divide it by square root of 25. And let's see what the answer would be right there. So all I need to change the 0.5 divided by square root of 25, which is 5. See the difference, guys? And look at the answer. It's 0.0808. It's not the same. So again, when you work with sample means, when you work with the X bar, remember not to use only the original standard deviation. Use the original standard deviation divided by the square root of the sample size, which he gave you right here. That ends the review.